It's Mr. Lawrence here, and we're going to continue our exploration of the big F word. Remember, the big F word is, whoa, wait a minute, what's going on there? That's not supposed to happen. I feel a sneeze coming on. Chew! It's factoring. Yes, the big F word is factoring. And we learned how to factor by the GCF. We're going to learn another type. Oh, my allergies are really acting up. Chew! All right, factoring by grouping. And you know what? Factoring by grouping is simple. If you understood how to factor by GCF, then for factor by grouping, here's what we're going to do. We're going to, first of all, we're going to factor by GCF, greatest common factor, and then we're going to factor again by the GCF, and then one more time, we're going to factor by the GCF. That's all factoring by grouping is. It's factoring by the GCF, greatest common factor. So let's get down to it and see how we do this. Now, by the way, grouping is usually done when there's 4 or 6 terms. We'll probably only look at the ones with 4 terms, but that's when it's usually done. Okay, I will show you how to do a trinomial, meaning 3 terms, by grouping, but for right now, we're only worried about 4-term polynomials. Okay, so let's see here. Here's problem number 1. We've got 4 terms, right? You see the 4 terms? Where my highlighter, I'll highlight them for you if you like. Okay, this is one of the terms, and there's a second term. Notice I grabbed the sign with the term. There's a third term, and there is the fourth term. Okay, so we've got our 4 terms. Now, we are going to group these terms together. The only rule to grouping them is that there must be a GCF, a greatest common factor, in each pair. Okay, it doesn't matter what that GCF is, it just means that they have to have a GCF other than 1. 1 won't ever help us in this situation. Okay, so I could do these two together, the 2x squared and the 10xy, because I see a GCF. I could do these two together because there's a GCF. I could put the y terms together. Why don't we do that? Let's put the y terms together. So I'm going to rewrite this, putting my x terms together, and then putting my y terms together. Remember, the commutative property allows me to rearrange the order of an addition problem, right? Okay, and so I am going to group these two together, and this is very, very important. When you group your second pair, always grab the sign. Always grab the sign. Notice that the sign moved with the 10xy. I took extra time to make that happen on purpose. Make sure you grab the sign, and then between the quantities, you have to put an addition sign. Otherwise, uh, it becomes a multiplication problem, a FOIL problem, and we don't want that. Okay, so now in this first pair here, I'm looking, what is the GCF of 2x squared and 3x? Well, I think it's just going to be x, right? And so here's what I'm going to do. I am going to divide both terms by the GCF, and that'll cause this GCF to go out front, right? I'm like undistributing it. Yeah, I'm factoring by the GCF. Okay, so 2x squared divided by x is going to get me 2x. And then 3x divided by x will get me a 3. Okay, that's the first factor by GCF. So I did step 1. Okay, step 2, I need to find the GCF of 10xy and 15y. Well, I think it's going to be a 5y, isn't it? It's going to be a 5y. And so, got to bring this plus sign down. See that plus sign right there? He comes down. I pull out my GCF. And what's left inside? Well, that's where the division comes in. 10 divided by 5 is 2. Xy divided by y is x. 15 divided by 5 is 3. Y divided by y cancel out. So I'm left with x times the quantity of 2x plus 3 plus 5y times the quantity of 2x plus 3. Now something should seem a little repetitive. Check this out here. what is x? Well, of course, it's a variable. But what else is it? It's a factor of this multiplication problem, isn't it? There are two factors in this multiplication problem, x and 2x plus y. So those are the two factors, okay? Now the two factors over here are 5y and 2x plus 3. Did you notice that I repeated myself? Yeah, I said the 2x plus 3 twice. That means it's a common factor to both terms. Since it's a common factor, I can factor it out. I'm going to factor out this quantity of 2x plus 3y. Now, factoring out is like undistributing, so it's like using division. So I'm going to ask myself, what happens when I divide this multiplication problem by the GCF, 2x plus 3. And of course, I'll have to do the same thing over here. Divide 5y times the quantity of 2x plus 3 by 2x plus 3. Well, let's see here. I've got this 2x plus 3. I factored it out. What's left from this problem? Well, looks like the 2x plus 3 and the 2x plus 3 will cancel, leaving just an x. Over here, looks like the 2x plus 3 and the 2x plus 3 will cancel, leaving 5y. Okay, there you go. You just factored by grouping. You GCF'd again, and you GCF'd one more time. Okay, it's really pretty simple stuff. Okay, so let's try it again. All right, I've got this problem number 2 here, and I'm going to rewrite it so that I have common factors together. I mean, I do have common factors 36 and 8, but they don't jump out at me. You know what's really jumping out at me? The 36 and the negative 45y. And notice the sign moved with the term. Yeah, I see a GCF there pretty easy. And then I've got this minus 8x and this positive 10. I like those. Now, it doesn't matter how you group them as long as there's a GCF in each pair. Okay, so here's what we're going to do. I'm going to group these two together, 36x squared y and the negative 45xy. I'm going to group the 8x, negative 8x plus 10, and remember, grab the sign, but then between the quantities, I will stick a plus sign. I have to stick that plus sign in there. If you don't grab the sign, you're going to make mistakes, okay? If you don't grab the sign and the sign is subtraction, like on the 8, you're going to accidentally turn the problem into a distribution situation, which it is not, and that will thereby change your answer. Okay, so I'm looking at 36 x squared y minus 45xy, and I'm looking for the GCF. And I'm going to write the GCF under here because that's what I'm going to divide by, and then I'll pull it out. Okay, looks like the GCF of 36 and 45, I think, is going to be 9. I'm not finding a larger one that goes in there. What's the GCF of x squared and x? Well, x squared is x times x. And then there's an x over here. What's the greatest factor of x's? You know, is it x squared? No, because there's no x squared over here. Okay, this one has x times x. This one only has x. They have one x in common, or better yet, an x to the first power in common. Okay, now they have y's in common. All right, there we go. My GCF is 9xy. 9xy. I'm going to divide both terms in the first quantity by 9xy. So I'm pulling out the 9xy, and now I worry about the division. 36 divided by 9 is 4. X squared divided by x would be x. Y divided by y cancel. Negative 45 divided by 9 minus 5. The x's cancel, the y's cancel. Okay. Here, my GCF. I think it's going to be 2, but I'm not going to pull out a 2. I'm actually, think about it a second. Notice my first quantity, in my first quantity, the 4x is positive and the 5 is negative. And my second quantity, I have a negative x term and a positive constant. it's backwards. It's not going to work. The quantities aren't going to match. I mean, 4x minus 5 does not equal negative 4x plus 5. They're not the same problem. Here, try this. Is 5 minus 2 the same as negative 5 plus 2? No way. One's positive and one's negative for the answer. So how could I change both signs when I pull out my GCF? Well, I'm actually going to pull out a negative GCF. I'm going to pull out a negative 2. 2 is the greatest common factor, but I'm going to pull out a negative. So I'm going to pull out a negative, and when I do that, I'm going to get rid of this plus sign because he becomes unimportant. 8, negative 8 divided by negative 2 is positive 4. There's an x coming along for the ride. 10 divided by negative 2 is negative 5. Okay, now if you look at the factors, let's check out the factors. We've got a 9xy and we've got a 4x minus 5 being multiplied together, right? Those are the factors. All right, here we have a negative 2 being multiplied by a 4x minus 5. There's the factors. Did I repeat myself? I did. I said that 4x minus 5 part twice. There is my third GCF. Um, Interestingly enough, this is the part kids have the most trouble with, and it's really the easiest because all you have to do is pull out that common factor, and then what's left? Well, the other factor, a 9xy, and then a negative 2. And look at that, you're done. Piece of cake. All right, we're going to do 2 more examples. I'll go through them a little bit quicker this time. In fact, if you feel up for this and you want to try it on your own, go ahead and pause the video. That would be the right thing to do. Okay, I don't think I'm going to rewrite this one. I like the order they're in. I got to stick a plus sign in between those quantities when I group them like that. My GCF, I think it's going to be a 6x. Yeah, I'm going to factor out a 6x from the first pair. So I'm going to have 6x times the quantity of 3x plus 4. Okay, now my GCF here, both terms are negative. I'm going to pull out a 7, but both terms in the first quantity are positive, so I'm going to pull out a negative 7. So I'm going to pull out a negative 7. Notice I didn't put the plus sign in because I pulled out a negative 7. I'll get a 3x, and then I'll get a 4. Oh, look at that. I've got a GCF of 3x plus 4. I'll pull out a 3x plus 4. I'll be left with a 6x minus a 7. And there we go. There is your answer. Okay, one more problem. This one I think I do want to rewrite. I really would rather put 40x squared with the positive 10x and the negative 24x and the negative 6 together. I like the way that looks better. There were GCFs before, but it's a little bit easier to do it this way, in my opinion, because I like the 40 and the 10 together. I like the two negatives together. Now, you don't have to rewrite it. It just jumped out at me that it would be easier. Okay, so I'm looking at this first quantity, and I'm seeing 40 and 10. I believe the GCF part will be 40, the numerical part, excuse me, and the variable part is going to be x. So I am going to pull out a 40x, and it looks like I'm going to be left with an x in the first part. And, oh, silly me, look at that. I said the GCF of 40 and 10 was 40. Absolutely not. I apologize. Going a little too quick here. It's going to be 10x, of course. 10x. Sorry about that. Okay, so I'm going to pull out a 10x, and I'm going to be left with a 4x plus a 1. This is very important. This is extremely important. 10x divided by 10x equals 1, not nothing. Canceling out doesn't mean nothing. Okay, if we were talking addition or multiplication, then maybe I'd let you get away with that. But not in, did I say addition or multiplication? Excuse me, addition or subtraction, canceling out turns to 0. but we are not adding or subtracting at the moment. We are dividing, and in division, canceling out turns to 1. Very, very important. Okay, looking for a GCF in here. I see both signs are negative. It's going to be a negative. Okay, and I think 6 is going to do the trick. So I'll pull out a 6. 24 divided by 6 is going to be 4. There's an x in there. Negative 6 divided by negative 6 is positive 1. Okay, so I have the quantity of 4x plus 1 times the quantity of 10x minus 6. And there we go. We're done. Okay, I'm not going to do any more examples right now. We'll get some practice with this over the next couple of days. Mr. Lawrence signing off. Have a good night, everybody.